Do you ever wonder why Earth is the only habitable planet in our solar system as of now? Are there any other planets that comprise of oxygen and water? Can life be sustained on other planets and maybe in other distant galaxies? Extraterrestrial life is the hypothetical life that may occur outside the premises of the Earth. Does such life exist, or is it just a myth? How far is the largest star? How large is it? How many galaxies are in the observable universe? The James Webb Space Telescope, JWST, is NASA's ambitious scientific endeavor to uncover such questions and dive deep into the unknown horizons. Is your mind oozing with curiosity to know the answers? Well, get ready as we take you on a trip across the galaxy with the James Webb Space Telescope and uncover unseen paradigms. In this video, we'll be talking about the James Webb Space Telescope, how it differs from the Hubble telescope, how it was launched, steps in image capturing, its capabilities, all about the entities that it will observe, and much, much more. Please watch the whole video till the end, where we talk about how NASA's James Webb Space Telescope's first study will include observing 19 neighboring galaxies. Also, we'll talk about the first ever image captured by the Webb. Stay tuned. Make sure to hit that bell icon to stay updated when our new videos come out. And don't forget to like the video, and of course, subscribe for more insightful content. So get ready as we uncover facts and unravel the depths of the universe. NASA's James Webb Space Telescope, JWST, is virtually a time machine worth $10 billion. Yes, you heard that right. With a B. This extraordinary piece of hardware has been in development for more than 20 years to achieve perfection. But what does it do exactly? How is it different from the Hubble telescope? Let's dive deeper. You may, in reality, or in a movie, see someone using a telescope. They point the lens towards a specific point in the sky and focus on it. The result is an amazingly close view of a star, planet, or most commonly, our moon. The James Webb Space Telescope is just that, but about a multitude of times stronger and better. Let's make a realistic comparison. The James Webb Space Telescope is 100 times more powerful than the previous Hubble telescope. Yet James Webb's primary lens is 113 kilograms lighter overall. It is 3 times the size of Hubble. After traveling nearly 1 million miles, the Webb is currently at its observing spot, Lagrange Point 2, L2, nearly 1.6 million kilometers away from Earth. Lagrange Point 2 is one of the 5 places in the solar system where the gravitational forces of the neighboring entities allow the object to remain in a fixed position relative to Earth. The James Webb was packed into a European Ariane rocket with many mechanical limbs and instruments, which included 5 layers of a thin, foil-like plastic stretched to the size of a tennis court to shield the telescope from the sun's heat. Later, when the telescope was deployed, it unveiled a 21-foot-wide array of 18 gold-plated mirrors. It is the largest and most powerful space telescope ever launched into space. The steps in image capturing include segment image identification, segment alignment, image stacking, coarse phasing, fine phasing, telescope alignment over instrument fields of view, and iterate alignment for final correction. Launching the telescope into space was the first tricky part, but others are yet to come. Scientists plan to spend at least 10 years using the telescope to study distant light from the beginning of time. To put the perspective of the power of James Webb into an example, consider you are 70+ million light years away from planet Earth and point a powerful telescope right at Earth. Viewing through this telescope, you would be able to see the prehistoric era, specifically the dinosaur era. There would be thousands and millions of obstacles in the path, but this is what we can achieve with a powerful telescope like James Webb. James Webb operates in the infrared spectrum, which ranges from 0.75 micrometers to 1,000 micrometers, which is a key skill that older telescopes lacked. There are a lot of obstacles that hinder or block the light coming from stars, but the infrared radiation can penetrate dust clouds, allowing the telescope to see the light. According to Einstein's theory of relativity, the universe is expanding, and so is the space between objects. As the distance between space entities expands, so does the light, allowing the light to stretch and enter the infrared spectrum. This is how the Webb can detect even the faintest of light, which can't be seen with a naked eye. So, are you wondering exactly how far back the James Webb Telescope can see? With Webb's larger mirror, it will be able to see almost the whole way back to the beginning of the universe, precisely around 13.7 billion years ago. Imagine seeing the formation of the first star. The first image captured by NASA's brand new James Webb Space Telescope was of a star warped over 18 different images. The single star repeats a hexagonal pattern, and the picture was released on the 18th of February 2022. The inconsistencies in the mirror's alignment caused the telescope to output 18 images. The most exciting part is JWST's accuracy. In theory, you could spot the heat signature of a bee at the distance of the moon. How exciting! This same process can be applied to study the rings and how they formed on Saturn, Uranus, Neptune, and Jupiter. With this technology, we can learn about exoplanets and their chemical composition of atmospheres to determine the presence of water and oxygen. But enough technicalities. You want to know what cosmic beings the Webb telescope will work on, right? James Webb will be observing the weirdly flickering black hole located at the center of our galaxy. The flickering nature of the black hole has proved elusive for existing telescopes to explore. Next, the Webb telescope will combine with the efforts of numerous telescopes to study the nature of Sagittarius A star, which is a supermassive black hole. Its tendency to constantly flare every hour makes it hard to image. James Telescope will image Sagittarius A star in 2 infrared wavelengths, from a perch in space unobstructed by any light. The flares occur as charged particles and are accelerated around the black hole to higher energies, which create these light emissions. The James Webb Space Telescope will also be joining forces with the Event Horizon Telescope, EHT, which comprises of 8 ground-based radio telescopes. EHT was responsible for capturing the first ever image of a black hole called M87 star in 2019. The reason the majority of the target research areas are black holes is because they might hold a clue to some big questions, like how the universe functions. This is just the tip of the iceberg in terms of the possibilities that the James Webb can do within its initial decade of research and observation. But what if something goes wrong with the telescope? Well, then sadly, there's nothing we can do. The James Webb sits at 1.6 million kilometers away from Earth, further than any human has ever traveled. So if something were to go wrong, it won't be possible to head into space and fix it. As we talked about at the start, the JWST will help us observe 19 neighboring galaxies and how they fit into our neighborhood's history. The infrared images obtained from deep space will allow James Webb's data to add galactic visual information about star formation, mature stars hiding in galaxies, and about strong winds blowing off of these stars. What should the telescope be observing first? Exoplanets? Black holes? Maybe some extraterrestrial beings? Join the conversation and let us know what you think in the comments below. If you enjoyed this video, check out our video on the insane billionaire race to space. And don't forget to destroy that like and subscribe button for more insightful content.